My dear students, welcome back to our class. I hope you're all doing well and healthy in this difficult time. Today's lesson is about thermoconvection. But before we go into the details of this process of thermoconvection, it's important to make a quick review of our previous lesson, which was about thermoconduction. In that lesson, we discussed a lot of things, how thermoconduction takes place, why thermoconduction is common in solids. We also discussed why metals are better thermoconductors than non-metals. We looked at different materials with different thermoconductivities and classified thermoconductors and thermoinsulators. How thermoconduction, how thermoinsulators may be used in real-life problems, especially the insulating properties of air. We discussed a lot of things. You need to go back if you like and check that video. On the same note, there are two corrections we need to make. While I was going through that video, I recognized some errors and we need to correct it. In minute 13:30, there is a statement that says you have to know that when you trap air, is this statement, when you trap air, it's not moving, then you have created a very good thermoconductor. This word conductor should have been insulator. You have created a very good thermoinsulator. Trapped air is a thermoinsulator, not a thermoconductor. That's a correction we need to make. Also in minute 15:10, the word thermoconductor should become thermoinsulator. Those are the two corrections we need to make in our previous lesson. But now we can proceed to today's lesson. Our objective is to describe the process of thermoconvection. Okay. Now, to understand thermoconvection, let me draw some few particles here. Let us say these are atoms of a gas. Now let me use maybe water, a liquid. So when you heat these particles, these atoms to be more specific, they gain kinetic energy and move faster and farther apart. So let us say this one goes here, this one will now be here. You see? So they move faster and farther apart from one another. In the process of moving farther apart, they occupy a bigger space. So initially, these three atoms were here. Now we are saying they have come here. But this is caused by heating. So when you heat an object, as the molecules move apart, they occupy a bigger space. And this means that this object will expand. We call it thermal expansion. So when you heat an object, it undergoes thermal expansion. The molecules push each other apart, making the liquid or gas to expand. That's the first point. When the liquid or gas is heated, it undergoes thermal expansion. It expands. And we are saying that expansion is because the molecules move further apart from one another. Now, expansion is an increase in volume. But I think you remember from your expression for density that density equals mass divided by volume. See? So if this mass is kept constant, then density is inversely proportional to the volume. That means when V increases, when the volume increases, the density has to reduce. Okay? The density reduces. Now, we are saying that whenever there is an increase in volume, the density reduces because of that inverse relationship. So now we go back to our discussion. We said when you heat a liquid or a gas, number one, it undergoes thermal expansion. So when that liquid, that fluid expands, it becomes less dense. It becomes less dense. And we have explained why it becomes less dense. Because keeping the mass constant, the density is inversely proportional to the volume. From that formula we have seen. Then when it becomes less dense, I think we are aware that denser fluids tend to go down and less dense tend to rise. See? So when the fluid becomes less dense than the surroundings, then this fluid will rise. See? This fluid will rise. And the cooler surrounding liquid or gas falls. This is what is happening here. This fire causes the air around here. That air heats up, number one. When that air heats up, it expands, or you can say it increases in volume. When it expands, it becomes less dense, its density reduces, and the less dense hot gas will rise up. This is shown by this red arrow. Then the cooler, denser air, which was up, falls to fill this vacuum created here. And this results in a circulation, in a movement of fluid due to that difference in density. That movement is what we call, that flow of fluid due to differences in density is what we call a convection current. So just to recap, what we are saying is that when you heat a fluid, number one, when you heat up a fluid, what happens? It expands. When it expands, what happens? Its density reduces. When its density reduces, what happens? It rises, goes up. Then what happens? The hot fluid, the hot fluid, as the hot fluid rises, the cold fluid at the top, which is denser, will fall to fill the vacuum created at the bottom. Then this results in a convection current. Those are the points we need to know here, and they are very important, as we will see. So now, what is convection? Thermoconvection is the transfer of thermal energy through a fluid, and this is accompanied by movement of the fluid. Compare this with thermoconduction. In thermoconduction, we said thermal energy is transferred by vibration of atoms or electron diffusion, okay? But there is no net movement of the fluid. Now here we're saying there is movement of the fluid. That's how the thermal energy is transferred. Then we have to talk about these convection currents in detail. So we are saying a convection current is a flow of a fluid caused by change in density. And as we were explaining, the less dense fluid rises, the cooler and denser fluid falls. There are many real-life problems of this. When you burn something, the smoke, you see the smoke going up? It's because of density. That hot air is less dense, so it rises. And this is a very common demonstration of convection currents. I think you have seen this kind of a problem. It's a common laboratory experiment we do during thermal convection to demonstrate. Now when you look here, we have a beaker filled with water, and in the bottom right, this part, some few crystals of potassium permanganate are dropped. Then when this part is heated, you can see the flame. When that part is heated, then we know what happens. Thermal energy is transferred through the glass by conduction. When this thermal energy reaches the water at this point will heat up. So that water heats up. It expands, becomes less dense, and rises up. You can see the purple, which corresponds to permanganate ions, the color of the permanganate ions, rising up. Okay, so this is showing you that the hot, less dense fluid is rising. Okay, and then the cold fluid, which was this side, will come in here to fill up that space. This causes a current circulating like that. In this case, it's moving counterclockwise. Okay, the fluid moves in counterclockwise direction. On the left, it's going up. On the right, sorry, it's going up, and then on the left, it's falling. So what happens here is that thermal energy is transferred through the glass by conduction. Then the water just above the flame becomes heated, expands, becomes less dense, and rises. Then when it rises, what happens? The cooler, denser water will fall to come and fill this vacuum created by the rising water. That creates a convection current. That's what happens here. And we also have convection currents in gases. Like here, it's a radiator used to heat up a room. This radiator must be placed at the bottom. We'll discuss those facts later. But the air in this region next to the radiator heats up. When it heats up, it expands. It becomes less dense. It rises, you see. So you see this arrow showing the hot air rising. Then the cold air, which was this side, will move in to cover this gap, that vacuum created by the rising hot air. This will create a convection current, and the air will circulate and heat up the room uniformly. This is a convection current. So you just need to know the points. The fluid becomes heated, it expands, becomes less dense, it rises. Then when it rises, the cooler and denser fluid will fall to fill the vacuum created by the hot fluid. This creates a convection current, and the process continues. That's what you need to know. Even this question is testing that. You can see we are told that the experimental solar updraft tower was built in the south of Spain, and the SUT, we are told this part of Spain has little rainfall and is hot in summer months. The SUT was used as a 50 kilowatt electricity generator. The diagram shows the components of the tower. Okay, it's here. This is the tower. It has a turbine. Then there is a cover. They're saying the cover allows visible light to pass through. So this radiation from the sun passes through, but the infrared radiations are trapped here. This is an example of greenhouse effect, but it's a topic for another time. Bottom line is that the infrared radiations are trapped inside here, and they make these blocks of material to be warm. These small rectangles you're seeing here, these ones, they heat up. So explain what happens to the air at A, just under the cover here. What happens here? Since these blocks are hot, number one, they heat up the air. So the air in contact with those blocks, with that block at A, will heat up. Air becomes hot. Then the air will expand. When it expands, it will become less dense. When it becomes less dense, it will rise. Those are 4 marking points. The question needs only 3. So when it rises, this air goes up like this. I think that is the next part of the question. But let us first continue with this. What happens to the air at A? The air becomes hot. The air will expand. It becomes less dense and rises. Then we know later the cooler and denser air will come in to fill that space, but only they want us to say what happens to this air here. Okay, so that air becomes hot, it expands, becomes less dense, and then it rises. Those are the 4 points for this question. You can give all the 4 points. Let the examiner give you what he wants. Only 3, but you have answered everything. On the diagram, mark the directions of the air movement over the blocks. So here, we need to show how the air moves. Actually, this air should move like that, towards the right and up. Then once it's inside this tower, it should go up like this. That's what happens inside. and then state the name of this effect. This effect is called convection currents. And that brings us to the end of our lesson. Try to answer this question. It's similar